जिसमें we'll try to understand what exactly a capacitance is. But I'll start in a very simple way. I hope you'll like it. Okay, so how to start it? First, you imagine a conductor, any arbitrary shape. This is a conductor. Okay, now what happens if I give some charge to it? That depends how you are giving the charge to the conductor, but let's suppose you are from outside, you are giving some charge to this particular conductor. Now as a result, its potential will increase. If you are giving positive charge, its potential will become positive. If you are giving negative charge, its potential will become negative. That you already understood in the previous electrostatics wala portion, right? Okay, so let's talk about cause and effect relation. Cause is proportional to effect. So any proportional relation in physics we are writing in this particular format. So beta आपने charge दिया. Anyway, like it doesn't matter how you are giving charge to this conductor, but you are giving some charge. So that is the cause. And what is effect? Its potential is increased. Now what exactly this V is? So V, I'll say it is body ka potential, and better to say in case of conductor it is surface ka potential, or you can simply say potential of the conductor also. Okay, now that proportionality sign you can remove by a constant. That constant is actually C. ये तो हो गया इसका mathematical version. How to understand C? Now physically इसको कैसे imagine करना है बेटा? So C equals to Q by V. So if I go by this formula, one thing is clear. If V equals to 1 volt, then C is equals to Q. Now what exactly it means? बेटा आपको कंडक्टर पे you have to put some charge, and as I said, its potential will increase, right? अब आपको exactly कितना charge body को देना है so that its potential become 1 volt. So that particular amount of charge given to the body is nothing, just the capacitance of the body, right? So capacitance, it's not related to the fact कि कोई body कितना charge hold कर सकता है. Its name is capacity, but misunderstood नहीं हो जाना बेटा name से. It's simply the actual meaning of capacitance is actually like how much charge you have to give to this particular body so that its potential becomes 1 volt. This is the way how you start learning about capacitor, right? इसको और explore करते हैं, बहुत मजा आएगा इसमें. Okay, अभी first I'll discuss only regarding this isolated conductor. Isolated का मतलब बेटा there is no conductor in the nearby. If it is there, then it will affect actually the overall charge distribution. So for time being, for simplicity, first I'll consider only isolated conductor. Okay, now if I take this type of shape, a conductor shape, or you can imagine a conical shape of the conductor, or you can imagine a cylindrical shape or perfect sphere, or you can even imagine a cubic shape, right? Now, one interesting question is how much charge I should give to these bodies so that their potential is becoming 1 volt. Imagine you have a particular piece of conductor. जैसे यही piece आप imagine कर लो बेटा. इसी को मैं mold करके, like I'm melting it or just molding it to another shape, ऐसा cone, फिर cylinder बनाया, फिर sphere and then cube. So in all these cases, what I'm going to do, I'm putting charge over them from outside, and I'll check कि कितना charge मैं इसको दूं कि इसका potential 1 volt हो जाए. Now the interesting outcome is they all will take different amount of charge so that their potential is getting 1 volt. इसको डीपली अगर समझना है तो एक फैक्ट्स आप समझ सकते हो बेटा. If I take a spherical body and if I'm giving some charge to it, it has some radius. So what is surface potential? KQ by R. If I change the radius, definitely its voltage is also changing. And in the same way, like अगर मैं इसी को distort करके कुछ इस type का मैंने shape अगर बना दिया, so definitely its surface potential will change. So potential has to do a lot with energy distribution. अभी इसके बारे में बाद में बात करेंगे, but अभी आप इतना समझ सकते हो कि for a particular body, the way how you are distributing charge over the surface, or basically what is the shape of the conductor, that actually decide कि body का potential कितना होना चाहिए. So if I take these different type of shapes and if I put same charge over them, q q q, but ये potential is not equal to this potential, not equals to this potential, not equals to this, not equals to this. So what we got here कि जो capacitance होता है body का, It actually depends on the shape of the body, better to say the geometry of the body, and that is very important. एक ही conductor लिया बेटा, देखो मैंने, you can imagine it as a copper, and then you are molding it to another shape, different shapes you are taking. जैसे ही आपने इसका configuration या फिर shape or size change किया, then its capacitance is keep on changing, right? So capacitance has a strong dependence on the geometry, directly related to the geometry. अब किस चीज पे independent होता है? Independent of nature of material and several other factors, temperature, color, mass, and all. There are various things, but ultimately it is independent of the material, like what kind of material you are taking. Even so, for example, if I take there are two spherical bodies, they both are conductor. Let's suppose this is copper, and then you have same radius ka aluminium. So C of Cu must be equals to C of aluminium. मतलब नेचर से इंडिपेंडेंट है, अगर आपका दोनों का डायमेंशन सेम रखोगे they'll have same capacitance. Even अगर आप different radius अगर किसी sphere का ले रहे हो, तो they have different different parameters. So if you change that, definitely you are going to change the capacitance of the body. Okay. एक और चीज है जिस पे capacitance depend करता है, वो भी आपको समझना है. See, imagine any conductor, let's say copper, and it has some capacitance C. मतलब कि we know the value of charge which will give it exactly 1 volt of the surface potential. Now field lines are emerging. If it is charged, field lines are emerging from it and they are going up to infinity. Now if I assume air in the surrounding medium or some other medium, this will definitely affect the value of C. मैंने क्या बोला था, शेप अभी तक ये यहाँ पे it is directly dependent on the shape, but it is independent of the nature of the material, but yes, it is dependent on the outer side का medium. So basically if I take air, so it will have some capacitance as C air, and that is not equals to C with this medium. This also you need to understand. Medium की dependence कैसे काम कर रही है, this I will discuss later. इसे actually presence of dielectrics भी बोलते हैं, that I'll discuss later. So two things you just understood here. एक है आपका geometry plus medium. These are the two strong parameters which are deciding कि किसी भी conductor का capacitance क्या होना चाहिए. ठीक है, लेट्स मूव अहेड. तो अभी तक मैंने बात करी बेटा यहाँ पे regarding an isolated conductor. Things are changing when you take multiple conductors. Let's start with only two conductors. So suppose you have one conductor here and one conductor here, right? And let's suppose I'm giving some charge to them. एक को positive क्यों दिया और एक को negative क्यों दिया. अब आप ये बोल सकते हो कि डिफरेंट चार्जेस भी मिल सकता है इन कंडक्टर्स को. सो दैट इज करेक्ट बेटा. एक्चुअली कैपेसिटेंस इज इंडिपेंडेंट ऑफ द प्रेजेंस ऑफ चार्ज. मतलब अगर आप प्रीवियसली इफ यू सी दिस, फॉर एग्जांपल दिस केस, मैं बॉडी को 2 कूलम का चार्ज दूं या फिर 5 कूलम और 10 कूलम, डजंट मैटर. what matters actually for the calculation capacitance is the amount of charge required to give the body a potential of 1 volt, as long as you're not causing any change in the shape. So charge से independent है बेटा, it's the ratio, right? Okay, so if I take two conductors, सिंप्लिसिटी के लिए एक को पॉजिटिव और एक को नेगेटिव चार्ज दिया, इस केस में आप कैपेसिटेंस कैसे डिफाइन करेंगे? सो आइसोलेटेड के लिए बेटा, आई ऑलरेडी टोल्ड यू द फॉर्मूला, द चार्ज ओवर बॉडी डिवाइडेड बाय इट्स पोटेंशियल. लीव इट, दैट इज फॉर आइसोलेटेड. नाउ इस केस में क्या काम करना है आपको? द फॉर्मूला विल चेंज. C equals to Q, you can take any one of the charge, better to say just the magnitude of charge here, and divided by potential difference. Divided by potential difference. बेटा न्यूमरेटर को लेके कंफ्यूजन नहीं होना है आपको. यू कैन ऑल्सो थिंक ऑफ इट दिस वे कि जैसे मैंने एक बॉडी से चार्ज को दूसरी बॉडी में ट्रांसफर किया, सो इफ इट इज गेटिंग क्यू इट विल ऑटोमेटिकली गेट Q, right? So it's basically what charge you are giving to the capacitor. So we are giving positive charge to the capacitor. Earlier it was neutral. Now I'm creating this difference of Q here, right? So I'm simply writing it as Q. So it is understood. Denominator is interesting. In case of two conductors, instead of V, I'll take delta V. Now, what is delta V? It is potential difference between the conductors. बेटर टू से उनके सरफेस के बीच का पोटेंशियल डिफरेंस. ठीक है, थोड़ा सा कॉम्प्लिकेटेड होगा बट हाउ टू अंडरस्टैंड इट, यू कैन इमेजिन इट इन दिस वे ऑल्सो. तो बेटा ये जैसे पॉजिटिव चार्ज है तो सम फील्ड लाइंस विल जनरेट और यहाँ पे एंट्री करेंगे फील्ड लाइंस. लेट्स टॉक अबाउट दोज फील्ड लाइंस जो सरफेस टू सरफेस ऐसे ट्रेवल कर रही हैं. And we know that if I go little bit in the direction of electric field, let's say for dl amount, the change in potential is given by E dot dl, where E is the electric field का variation between them. यहाँ पे तो मैंने कुछ arbitrary shapes ली हैं, so we actually don't know कि how that E is varying. But if you have two plates, then we know that electric field का variation, या फिर two concentric sphere or two concentric cylinder. In that case, it will be easy to imagine. ये मैंने just arbitrary shape ले ली, तो we don't know the actual variation of E. But yes, this is the way how you are finding the potential difference. Not integral, just this thing. Now, if you want a bigger change, you have to integrate this. That will give you the potential difference between the two surfaces, correct? And this particular formula you're going to use for two conductors. So generally आपके पास formula क्या हो गया? V equals to Q by, you can choose a mod here, integral of E dot dl. This is for the case of two conductors, and C equals to Q by V, surface का potential for isolated body. अब आप क्वेश्चन यहाँ पे ये पूछ सकते हो कि what if we have a case of more than two conductors. बेटा तब चीज़ें बहुत कॉम्प्लिकेटेड हो जाएंगी, एंड इवन दैट्स नॉट इन योर सिलेबस, एंड इवन मैंने अपने हायर स्टडीज में भी नहीं पढ़ा वो केस, बट लेट मी जस्ट गिव यू एन आइडिया हियर. So you have one conductor and you have this second conductor and then you have third conductor, right? So we have filled in between them, matlab you will have a field in this section, field in this section, field in this section. So each body, if they have charge, they are generating field in the entire space in between them, and like starting from them and going up to infinity also. So in this case may we are not defining the capacitance of a single body. Here what we will do, we'll have the capacitance of system. And how to find it? I mean, let me just give you idea, I'll not calculate it. एक तो हो गया individual, self plus C mutual. जैसे for this interaction you can find, for this interaction you can find, for this interaction you can find. So this is just a theoretical version to find out C of the system. या C of the system का मतलब क्या है कि मैं सिस्टम को कितना चार्ज दूं कि इस पूरे सिस्टम का पोटेंशियल 1 वोल्ट हो, बट पूरे सिस्टम का पोटेंशियल इज अ डिफरेंट थिंग. दो बॉडीज में भी इट इज इजी टू इमेजिन, इट्स लाइक यू आर फाइंडिंग द पोटेंशियल डिफरेंस बिटवीन द सरफेस, बट थ्री बॉडीज और मोर देन थ्री बॉडीज के लिए you have to think differently. It will be like a mutual or a common potential difference between, not common, it's like mutually you're going from 1 to 2, 2 to 3, and 3 to 1, like that. So that's a little bit difficult. Even I don't have much clarity about this topic. But just as a thought, a question, I'm discussing it. So we'll stick strictly to either single body or this combination of two conductors. Okay. कैपेसिटर को समझने के लिए देयर इज वन मोर व्यू पॉइंट, और यू कैन से एक डिफरेंट थॉट हियर. एंड सी, एज अ टीचर I start discussion of capacitor like this, but later on I'm dragging it to energy concept. तो कैपेसिटर को एनर्जी के टर्म्स में समझना भी important है. Like what's the use of capacitor and why we are studying it. See, if I say every capacitor has some energy, and how it's making any sense. So suppose you have a sphere, it has some radius, and I'm giving some charge to it, and we know कि इसका electric field will start right from the surface, it will go up to infinity, right? Now if I take any positive charge in this field, definitely it will start moving and it will gain some kinetic energy. Now the question is, who is giving it this kinetic energy? the electric field of the sphere. So electric field got a capability capability to do work, right? So electric field is holding energy, जिसको आप अपने previous chapter में पढ़ा भी होगा. So it's like the whole, the total energy associated, the field energy associated with the body. Correct. So capacitor को आप as a energy holding device भी imagine कर सकते हो. See, this particular spherical body is a capacitor and it is holding energy in the form of electric field. So energy होना is important नहीं है बेटा. The control of that energy is important. So if there is any way to confine this electric field का energy and then later we can use it as per our requirement, that is the whole idea of capacitor. अभी आप आगे पढ़ोगे यहाँ पे. So you have जैसे example के लिए two metallic plates, एक positive charge एक negative charge, and let's suppose this is grounded, and then you have electric field lines between them. बेटा ground कर दिया, that is the reason कि यहाँ पे और यहाँ पे electric field lines will be zero. So you have energy confined only between these two plates, and this is more reliable situation कि भाई ठीक है, मेरे पास एक system है and I have confined electric field lines, those energy bits inside this system. I can use it later. I mean, I just simply need to connect two wires. If I just remove it from the ground and just take two wires और यहाँ पे आपने एक LED bulb लगा लिया, then it will start glowing. ओके. सो कैपेसिटर का काम यही है बेटा. अगर आप आगे इन फ्यूचर ऑल्सो इफ यू आर स्टडिंग एनीवेयर रिगार्डिंग कैपेसिटर लाइक कैपेसिटर बेस्ड बैटरीज एंड ऑल, so that's the whole purpose of capacitor. They are holding energy. I'm not doing the proof here, but you must have studied this in your class. The energy associated with any capacitor, which is basically the electrostatic potential energy or field energy, it is given by the charge over the body, q square by 2c. Obviously charge ज़्यादा होगा तो field strength will be higher, so q square by 2c, and this c is the capacitance of the body. If it is isolated, then it is c for the body. If it is a combination of conductor, then it will be c system. So basically it is c system or c isolated. Both cases you can imagine. Okay, so next I mean from this particular things onward, you can imagine capacitor as an energy holding device. That way you have to imagine a capacitor. Okay. So let me take few problems to understand it, then I'll start the rest of the topics, right? So let me take one problem here. Uh, so the problem is, imagine you have a spherical body, let's say a conductor, basically it has radius r, और आपने एक metallic plate ऐसे लिया और एक metallic plate ऐसा, and this portion is grounded, and then you imagine there are 2 point charges q and this also q. They are approaching this conducting sphere. Rest of the medium you can imagine as air. Okay, so the question is, you have to find out, uh, I mean, let's suppose when it is at a distance of x from the center of sphere and this is at a distance of y from the center of sphere. So at this particular instant, you have to find out q over the capacitor, right? How to approach it? See, this charge is approaching from the right and it is going up. So basically, beta, they will induce a negative charge. This will induce negative charge. This will induce negative charge, right? Because these are positive charges. तो ये वाला जो portion है ये हो जाएगा positive, correct? But this part of the sphere further connected to another conducting plate. So what will happen? इसको electron चाहिए ना, तो ये इलेक्ट्रॉन्स खींच के यहाँ ले आएगा एंड दिस विल बी नेगेटिव और ये प्लेट को मिल जाएगा पॉजिटिव चार्ज. अब ये पॉजिटिवली चार्ज है जिसको इलेक्ट्रॉन चाहिए, इट विल आस्क टू द नेक्स्ट प्लेट बिकॉज ऑफ इंडक्शन इट विल कैरी इलेक्ट्रॉन्स फ्रॉम द ग्राउंड एंड इट विल बिकम नेगेटिव, करेक्ट? दिस वे. अब देखो ये जो पूरा स्फेरिकल बॉडी है, इट विल गेट सम, let's say for example it is getting minus q charge and of course it is bound charge or you can say induced charge. तो अगर इसको minus q है तो बेटा it will be automatically plus q और ये minus q, right? So I'm saying देखो ये conducting spherical body भी capacitor है और ये भी capacitor है, but the question is related to this capacitor, like what is the charge over it. करेक्ट, यहाँ पे स्फीयर के बारे में बात नहीं हो रही. दिस इज कैपेसिटर. एंड why exactly I'm saying only this capacitor? Because this is the basic symbol of any capacitor, two parallel plates. I'll discuss it later, but that is the actual symbol for any capacitor. Physically चाहे वहाँ दो प्लेट हो या ना हो, but by symbol we are representing any capacitor like this. Okay, now how to solve it further? I'll use this formula beta. C equals to Q bar, better to say Q equals to CV, this relation. V is the potential difference. यहाँ बेटा ये जो potential difference है between two plates. How to find it? Let's find out potential over the sphere. देखो ये वाला पॉइंट तो ग्राउंड से कनेक्टेड है बेटा, तो यहाँ अगर पोटेंशियल जीरो है, सो दिस इज ऑल्सो जीरो पोटेंशियल. सो वट एवर पोटेंशियल यू हैव हियर ओवर दिस प्लेट, एंड दैट इज एक्चुअली द पोटेंशियल ऑफ स्फीयर ऑल्सो, क्योंकि दोनों डायरेक्टली कनेक्टेड है. तो this delta V is nothing just V. And how to find out V? So let's find out potential over sphere, क्योंकि बेटा यही आपका इक्वल टू V है. कैसे फाइंड आउट करेंगे? You find out potential at the center of sphere, right? And that will be equal to potential over the surface. We know this thing from electrostatics chapter. So as I said, when left charge is at a distance of x and this lower charge at a distance of y, इन दोनों चार्जेस का पोटेंशियल कितना होगा बेटा? K q by x over the center plus kq by y, and as I said induced charge is minus q, so minus kq by r, minus kq by r. Okay, now this is the potential over the surface. Surface of what? Surface of this spherical body, and that is also the potential difference between these two plates of the capacitor. So if it is having charge q, we can also write it as V as q by c, right? Just see this thing, just equate them. So kq 1 by x plus 1 by y, and this side if I take q 1 by c plus k by r, this will be in plus. Okay, now from here you can simply calculate q as kq by 1 by x plus 1 by y divided by 1 by c plus k by r. Simple. So now see this next problem. You have a cell or battery and it is connected to two conducting spheres, radius r1 and r2, and the separation between their center is d, which is actually very large as compared to r1 and r2. Why we are taking large separation? Because the charge distribution over one sphere will not get affected by the charge over the another sphere. So basically their surface potential, which is kq by r, will remain intact, right? So you have to find the force of interaction between them. Definitely, see this battery, what is the work of battery here? It will take charge from one sphere and it will give to other one. See, basically this complete thing, this distribution, not this is this arrangement of two conducting sphere is actually a single capacitor. So I'll say it as C system. So within this system, this battery is going to give some charge, not giving from outside, it is simply carrying charge from here, it will give it to this. So अगर बेटा इसको Q मिला तो it will be negative Q. Now as per the formula, C equals to Q by delta V. And one more thing, this battery will keep on giving charge from one body to another till up to a point जब इन दोनों के बीच का या फिर आप बोलो surface के potential का difference becomes equal to V. So basically this Q is nothing just V. And what's the value of V? Which is delta V. It is surface potential between these two spheres. So KQ by R1 plus KQ by R2. Y plus एक positive एक negative, so negative negative it is getting positive. Okay, so if I take this relation, C equals to Q by this KQ by R1 plus KQ by R2, so C will become 4 pi epsilon naught 1 by R1 plus 1 by R2. How to find out charge over this particular capacitor system? So Q equals to C delta V, which is actually V. आपको given terms के basis पे बेटा निकालना है. So Q will become 4 pi epsilon naught R1 R2 by R1 plus R2 into V, then see they both have same charges, right? So force of attraction, a positive एक negative, will be K Q square by D square. That's it. Q you have and D you have already. Okay, see this next problem. So you have two conducting spheres. They are having charges like Q and minus Q. They are separated by distance D. Again, it is large as compared to their radii. Now you have to find out C for this particular system from the expression of U of the system. U is representing total electrostatic energy of the system. Previous case में हमने कुछ इस टाइप का किया था and it's easy to calculate directly from there, but we have to find out C in this case from the expression of U. So it's not just a question, it's just you can say it's a part of theory. So see these two conductors, this particular arrangement you can imagine as a single capacitance. So you'll have C system for it, and it will have energy which is given by Q square by 2C, right? So I'll do one thing, I'll find out energy from the another method. In electrostat you did it, right? The self energies plus the interaction energy. So U of system, self energy for first, Q square by 8 pi epsilon naught A, Q square by 8 pi epsilon naught B, and then minus uh, they have interaction k q1 q2 by r, so it is q square by 4 pi epsilon naught d, the separation between them. इसको थोड़ा सा और सिंप्लीफाई करो, q by 4 pi epsilon naught 1 by a plus 1 by b minus 2 by d, right? And this you can directly compare with q square by 2c, because the overall energy you can write it as a energy of a single capacitor, right? So यहाँ पे C का value will become, so Q square you can cancel out, so this will be one more thing, okay, sorry, you have to take 8 outside and then this will become 2 by D, so that's my mistake anyways. So this C will become 4 pi epsilon naught then 1 by A plus 1 by B minus 2 by D. That is the capacitance for this particular system. Here if I take a case, if D is very large as compared to A and B, basically the separation is so huge that there is no interaction between them, a very feeble interaction between them. So in such case this term will tends to 0, so C will become 4 pi epsilon naught 1 by A plus 1 by B, and that is similar to the previous case. So this is the second part of the video where I'll discuss multi-conductors together. Like I'll take only two conductors. So here I'll be discussing parallel plate capacitor, spherical capacitor, cylindrical capacitor, like that. I'll not go into the derivational part, but I'll give you a very good insight into it. Okay, so first if I say parallel plate capacitor, very straightforward we will go. You have two conducting plates. एक के ऊपर सपोज आपने चार्ज दिया Q और दूसरे Q1 let's say, and it is Q2. So better I'm not taking one positive one negative. Basically see it is independent of आप charge कैसे दे रहे हो capacitor, because capacitor is a different quantity. It is dependent only on the geometry. जैसे यहाँ plates का area कितना होगा, separation कितना होगा, and all like that. So let me start with very general situation. So एक के ऊपर मैंने charge Q1 दिया और एक के ऊपर Q2 दिया. Now we know one thing, if I place such two plates together, charge plates, the outermost sides पे Q1 plus Q2 का half, Q1 plus Q2 का half, correct? Then यहाँ पे you'll get Q1 minus this, so you'll get some positive charge here and some negative charge here. What is this value? Q1 में से आपको ये minus करना है, so it is Q1 minus Q2 by 2, ये positive में, and this will be Q1 minus Q2 by 2, ये negative में, right? So यहाँ पे you have some positive charge, negative, and you have some positive charge. तो बेटा field lines आपकी यहाँ भी रहेंगी, यहाँ पे and this way outside. Now अगर आप कैपेसिटर को एज अ एनर्जी स्टोरिंग डिवाइस की तरह इमेजिन करो तो कंफ्यूजन यहाँ से स्टार्ट होता है बेटा. As I said, I'm not going into the proper derivation, but whatever I'll give you here, that's very interesting. So you have fill lines in the leftmost portion. So you have energy in this section, right up to infinity. You have energy in this section. Better to say you have energy in this section. You have energy in this section. So this is a combination of two parallel plates, charge plates, and then you have the whole region, right from negative infinity to positive infinity. The whole space is filled with लेफ्ट से राइट जाते हुए the whole space is filled with energy. तो कैपेसिटर के पास एनर्जी कितनी होगी और कैपेसिटर कहाँ से कहाँ तक आप डिफाइन करोगे? दैट्स वेरी इंटरेस्टिंग प्रॉब्लम हियर. सो आपको करना क्या है बेटा? कंफ्यूजन हटाने के लिए, see, even in your textbook or in your class, faculties are, I mean, your teachers are directly teaching this way. कि बेटा, you have a positive charge here and negative charge here, and you have filled only between these two plates. But in the previous case, I just discussed you have filled on either sides also. Okay. So there is a term in case of capacitors that is called filled confinement. Filled confinement, and this is very important to understand here. But if I take the previous case, तो you have filled in between them, तो plates के बीच में दोनों filled add up हो जाएंगे and you'll get some filled, and you have filled here and you have filled here also. Let's say E1, E2, and you have E3. All three fields are holding energy. Now, if I talk about E2, which is between the plate, it is confined. Basically, it is more, aligned, because positive से निकलने वाली fill line की tendency negative की तरफ होने की होती है. So basically, they will all move towards the negative part of the plate. So within this particular section between the plate, fill lines are more confined. Basically, they are, they are captured, or you can say they are remaining localized within the plates. But what about these left and right going fill line? They are going up to infinity. They're going up to infinity. They are disorganized. So energy वहां पर भी है, but they are disorganized. They are not spatially, there is no confinement for them. तो capacitor आप पढ़ो, that is one thing, but this field confinement also you need to understand कि capacitor आपने क्या लेना है. तो ये left going, this is not capacitor. Right going, this is not capacitor. Whatever capacitor you have, only in between the plates. एक और तरीका है समझने का इसका, अगर आप लेफ्ट गोइंग प्लेट को अगर आप इन्फिनिटी तक फील्ड लाइंस देखते हो, so potential difference, which is E into that separation, let's say some up to infinity you are going, no? So this will tends to infinity, right? Now capacitance C will be some charge by delta V, so that tends to infinity. So these right and left and right wala sections you'll not consider as capacitor. Only the middle section where fill lines are confined, that you'll consider capacitor. And that is the reason in your class you directly study a parallel plate capacitor like this. Why we are using this particular system? Why not simply two plates? So if I take this situation, if I give some, let's say, charge Q to this, and doesn't matter what charge you are giving to this another plate, let's say Q2. So first of all, uh, because of this Q1, the whole charge will appear here, right? And here you'll get negative. And we know one concept from the previous electrostatic chapter: if one of the plate is grounded, the outermost cell pe, sorry, outermost plate, so you'll get zero charge, right? So the whole positive charge will here and the whole negative charge will here. But this time, this negative charge is not Q2. It's not Q2. So what is the actual figure? This will remain Q1 because it is not connected to any other plate or ground. But if I talk about this another plate which is connected to the ground, see, all these positive charge need a negative charge equal to them. So irrespective of initial charge over this plate, ultimately this will become minus Q1, because जो भी charge है, it is getting exchanged with the ground, और Q1 पॉजिटिव Q1 को चाहिए नेगेटिव Q1, तो उतना ही सेटिस्फाई होकर यहाँ पे मिल जाएगा आपको. So irrespective of what charge you are giving to the grounded plate, ultimately the situation is finally like एक के ऊपर चार्ज Q है तो इसके ऊपर नेगेटिव Q, and this is the standard parallel plate capacitor का figure. In this case you have zero electric field on either side, and in between these two plates you have the addition of the field due to both of them, and the net field is sigma by epsilon naught. And if D is the separation between them, then delta V, potential difference, them is become E into D, and later on you can just put the value of E, and further sigma equals to Q by area. So using all these relations, you can easily calculate epsilon naught A by D. And you can clearly see area and D separation between them. These are geometric parameters, and epsilon naught is representing that you have air between them. If you have any other medium, definitely this C will change. तो आप पैरेलल प्लेट कैपेसिटर जब भी आप किसी को समझाओगे या फिर आप पढ़ोगे, दिस पर्टिकुलर फिगर यू विल टेक एज अ स्टैंडर्ड. बट व्हाट अबाउट द अदर केसेस, जैसे मैंने बताया आपको कि ठीक है, नन ऑफ देम इज कनेक्टेड टू द ग्राउंड. लाइक एक के ऊपर आपने सपोज क्यू चार्ज दे दिया और माइनस 2 क्यू चार्ज दे दिया. ऐसे केस में क्या है कैपेसिटर? डेफिनेटली इन बिटवीन द प्लेट्स यू हैव टू टेक. सो द रियल रीजन इज you first distribute the charges. So total charge is q minus 2, that is minus q. So ये minus q by 2, and this is minus q by 2. So q minus q by 2, so minus minus. So basically this will be 3q by 2. If I add them, you are going to get this q. So ये कितना हो जाएगा? Minus 3q by 2. So as I said, this is not a capacitor. This is not a capacitor. Definitely they are holding energy, but again, that field confinement ka concept is important here. You have confined field within the plates. So charge on capacitor is actually 3q by 2. Got it? Concentric conducting spheres. You have one conducting sphere, you have another conducting sphere. और यहाँ पर standard figure की अगर बात करूँ तो you have to ground the outer one, not the inner one, the outer one. Why? In that particular scenario, first let me take radii A and B. So if I give some positive charge to the inner sphere, this will induce a negative charge. This will induce a negative charge on the inner side of outer sphere. And this outer sphere is connected to the ground where potential is 0. So this charge is getting 0, not because potential 0 to charge 0, but in this particular scenario you are getting 0 charge. This you can prove in a very easy manner. So you have again the field only between these two plates. देखो यहाँ तो electric field 0 और यहाँ electric field 0. If I don't take this grounded thing here, so you'll have field here and here. It is going up to infinity. So capacitor will become little bit tricky. I'll explain that part also. But since again you have to take care of that confinement, so only between these two spherical conductors we have electric field confined between them. So this is a standard figure of any concentric conducting sphere, and in this case, how to calculate C actually? First you need to find out potential difference. For that, E dot dl, where E equals to kq by r square. R is any arbitrary distance. I'm not going again into the proper detail of the derivation. So using this, C you can calculate 4 pi epsilon naught 1 by A minus 1 by V. So after finding this V, delta V, by putting the value of E, finally you can actually calculate C as Q by delta V. So this relation will directly give it to this particular relation. C equals to 4 pi epsilon 1 by A minus 1 by V. In the same way, if I take two long concentric cylindrical, not concentric, better to say, they have common axis of coaxial. These are large in length, but I'm taking a particular length here, lambda. So again, you have to ground it. Now, what's the purpose of grounding it? Because you want to confine electric field only within this region. So inside E0, outside E0. Again, in this case, delta V is E dot dl, and finally you'll get C. Basically, in this case, you have to define capacitance per unit length, not for the whole length because it's going up to infinity on both sides. So better to define capacitance per unit length, so which is 2 pi epsilon naught, and it will be ln, let's say this is A and outer radii B, so ln B by A, right?